The rectangular coordinate question will now be addressed from the January 2018 paper from Highways and Surveying 1. In order to establish horizontal control for a new civil engineering project, a closed traverse has been conducted. Its shape and orientation are shown in the diagram below. Following the traverse observations, horizontal distances and whole circle bearings have been calculated from the observations, and these are shown in the table. Line TV1 to TV2 is listed here and is indicated as such on the diagram. The distance is the distance between TV1 and TV2, and your whole circle bearing is from TV1 going clockwise all the way around until the line or the bearing intersects the line TV1 to TV2. The same can be said for line TV2 to TV3, where your whole circle bearing starts off at TV2, spins clockwise all the way around until it intersects the line TV2 to TV3. And the process is continued. The first part of the question requires you to draw up a traverse computation table, calculate the partial coordinates for each survey line and hence the closing error of the traverse. And this is worth 5 marks. Here you can see an example of a traverse computation table. You'll note that we have several different columns. One for line, one for distance, and one for whole circle bearings. This information will be provided within the exam itself. You will then need to establish your partial coordinates of eastings and northings, and then establish what corrections need to be made and apply those accordingly. Now the aim is to use the coordinates for TV1 in order to establish the rest of the coordinates for the additional stations. It's advisable to start the procedure by noting all of the stations required. You will see that we'll end up with station TV1, and this will be used as a double check. It's now necessary to transfer the information that you've been given onto your traverse computation table, i.e. you'll need to put in the lines, the distances and the whole circle bearings. Remember to leave the first row blank. Now that the data has been recorded, you're now in the position to calculate your delta eastings and delta northings, or partial coordinates. This is carried out by using the following formula. Your partial coordinates for eastings is distance times the sine of the whole circle bearing. For delta northings, we will use the cosine. So, we will take our distance to start with and our first whole circle bearing for the line TV1 to TV2. Remember that we are only measuring to millimetres and therefore working to 3 decimal places. In this instance, we can see that the delta eastings have been calculated to minus 9.257 of a metre. Looking at the diagram, we can see that TV2 compared to TV1 is in a westerly direction. We can now use our calculator to calculate delta northings. And this is done by simply moving the cursor, deleting sine and replacing it with cosine. Notice how this figure has been rounded up to 85.040. This calculation shows us that in relation to TV1, TV2 is just over 85 metres north. You will now be required to calculate the rest of the Delta Eastings and Delta Northings for each one of the survey lines. Once your Delta Eastings and Delta Northings have been calculated, it will now be necessary to calculate the sum of each in turn. This is in order to establish what error, if any, has occurred whilst we were doing our observations. With this example, you can see that we have an error of 17 millimeters on our Eastings and 20 millimeters on our Northings. So what does this mean? Well, if we have a look at this diagram, we can see our original position of TV1 to our measured position of TV1. And you can see that the differences on the Eastings and the Northings can be shown in a triangular format. By knowing our error allows us to calculate our closing error. And this is done via Pythagoras. Because the errors are both positive on Eastings and Northings, our correction will therefore be minus. So for our Eastings, we will apply a correction of minus 17 millimeters, and for our Northings, we will apply a correction of 20 millimeters. The error will be distributed as evenly as possible. And therefore, with our Eastings, we will deduct 4 millimeters from the first 3 readings and 5 millimeters from the last. For our Northings, it's a little bit more straightforward, as 5 millimeters will be deducted from each reading. It is good practice to sum up each of the corrections to ensure that they correspond with the initial values. It is now necessary to start applying those corrections to your original calculated Delta Eastings and Delta Northings. Remember to take care during this process, as it is easy to mix up the numbers in the different columns. I prefer to calculate all of the corrected Delta Eastings to begin with. However, the choice is yours. In order to check your calculations, the corrections of each Delta Eastings and Delta Northings should be summed. They are only acceptable if 0 has been achieved. By taking the Eastings and Northings of station TV1, we are now in a position to calculate the remaining Eastings and Northings of the rest of the stations. Eastings and Northings of station TV1 can be written as shown, and this is why we leave a blank space at the top of the booking sheet. By using the Eastings of station TV1 and applying the corrected Delta Eastings, we can now establish the Eastings for station TV2. The same process follows, but now we will use the Eastings of TV2, apply the corrections to find the Eastings of TV3. By calculating the coordinates back to station TV1, we can check to see whether our calculations have been correct. The process continues with calculating the northing coordinates for each of the stations.